Hey math kids, today we're going to talk about zeros, roots, and factors. They have a lot of stuff in common, but they are a little different. So a zero of a polynomial is a value of the variable which makes the polynomial equal to 0. Okay, so if we have x squared plus 2x plus 5 equals 0, it's whatever value we could plug in for x to make this true. So we can find that often by graphing it and looking at the x-intercepts. Now the roots, so this was for zeros. Okay, now roots. The roots of a polynomial equation are the solutions to the equation. Okay, so if we were just to solve this, whatever x values made this true would be the roots. Okay, and then it says the roots of p of x equals 0 are the zeros of p of x, and the x-intercept of the graph of y equals p of x. So conceptually they're different, but in practice they're pretty interchangeable. So don't worry too much about the differences between them. There is a good, if you just look in your book in this section, it's in a blue box and you can read it and really try to understand the differences between it. Okay, now let's try an example and see how it goes. So it says find the zeros of x squared minus 4x plus 53, and then also find the zeros. Okay, so if you're finding zeros, you're trying to find the x values that make each of these things equal to 0. So even though it's given, it's not given that these equal 0, it's implied by asking you to find the zeros. So we're just going to do quadratic formula. So a is 1, b is -4, c is 53. So we're going to do b plus or minus, not b. We're going to do 4 plus or minus -4 squared minus 4ac 2a. This is equal to x. Okay, so the bottom goes to 2, that goes to 53. 53 times 4 is 212, so we have -212, and then this is going to be 16. Okay, and then if we combine those, we get -196 over 2, like that. Okay, now 196 is 14 times 14. So this is going to give us the negative, we're going to pull out as an I, and, whoops, not that. Since 196 is a perfect square, we're going to get 14i. All of that's over 2. We can divide each piece by 2, and that's going to give us 2 plus or minus 7i, and those are the zeros. Okay. Now over here, the best way to approach it is to factor out a z first. Then we're going to set each of those equal to 0. This one's already solved. And we're going to square root both sides, pull out the negative as an I, and then call it that. So the zeros are 0 plus or minus I square root of 3. Okay? All right. Now they're asking us to factorize. So if we're going to factor this, we want to first pull out an x. Then that leaves us with a quadratic, which we can use box method. So 2 times negative 3 gives us negative 6. 1 and 6, 2 and 3. If we do 6 minus 1, that works. Or if we do 2 plus 3. Now because when we multiply this one we get a negative 6, that's the one we want to use. We set up the box. Okay, we can factor out a 2x, factor out a negative 1, factor out an x, factor out a 3. Multiply those back just to double check the signs are correct. And it works. Don't forget about this x either. So when we factored it, it's x, then it's 2x minus 1 from here, and then it's x plus 3 from here. And so that's our factored version of that. Okay, same directions. They want us to factor this. Okay. Now, this one we would want to try t-factoring, but there's no combination that adds up to 4, so we're going to have to approach it different. What we're going to do is we're going to find the 0 and then kind of go backwards from there. So we're going to plug this into the quadratic formula. And so we get negative 4 plus or minus 4 squared minus 4ac 2a. Simplify that. So that's negative 20. Alright, so we want to break this up. 10 and 2, 2 and 5. Okay, the negative comes out and we get an I. These 2's can come out, so it's 2i. The 5 has to stay back. And we still have our plus or minus. And 2. And since this, and this are all divisible by the same number, we can divide that. So we get negative 2 plus or minus I root 5. Okay, so those are our zeros. But when we go from 0 to factored form, here, I'm going to even write them out separately. So there's one of them, and then negative 2 minus I root 5. There's the other one. Now if we have our zeros, or our roots, and we want to go back to factored form, we just do, oh, I changed that to an x. Should be a z throughout this problem. Okay. We're going to say z minus so that's the first one. Then the other one's going to be z minus the other one. And if we distribute that negative throughout, this one's going to become z plus 2 minus I root 5. And this one's going to become z plus 2 plus I root 5. And so the two purple ones right there represent, they should be multiplied together. So I guess I should write them next to each other. So your final answer would look like that. Okay, let's keep going. Okay, it says find all real cubic polynomials with zeros 1/2 and negative 3 plus or minus 2i. Okay. So when we're doing this, it's going to be kind of like the last part of what we just did on the previous one. So Actually, let's approach it a little bit different. So we're going to look at there's a method we could use. Let's see, I think the book explains it somewhere. I don't know. It's probably in there. I can't see it right now, so I'll just explain it. So if we look at these zeros right here, if we add them together, so if we do -3 plus 2i plus -3 minus 2i, if we add those together, so we we combine like terms, we get -6, and then these would cancel. So this would be our sum. And then if we multiply them together, we're going to get product. We're going to do -3 times -3 is 9. -3 times that is +6i. That is -6i. And then that times that is going to be -4i squared. Cancel, change the sign. 9 plus that, these cancel. 9 plus that is 13. Okay. So what that means, there's a shortcut that we can use, is that these come from x squared plus the sum plus the product. Okay. And if we take this one, we can say that x minus, this is going to come from the linear factor that looks like this, which might be kind of hard to see. So if you just think of it as x minus 1/2, or even this, do this. X is equal to 1/2. Subtract 1/2 from both sides. So x is equal to -1/2, or not equal to. X minus 1/2 is equal to 0. And then if we want this to be a whole number, we could multiply everything by 2. And that's going to give us 2x. 2's will cancel, -1 equals 0. So the two factors that we have are these. And then we could multiply it out to get like a full-blown like polynomial, but it's okay just to leave it like this. And then since we want any, it says any polynomial that's like that, we're just going to put an a out in front, and we'll say this is our polynomial. Now, of course, a cannot equal 0, because that would just make the whole thing go to 0. Okay? Now, it wants us to find all real quartic polynomials with zeros in this form. Okay, so quartic just means x to the fourth, like a fourth degree. So we're going to start it off the same way. We're going to find the sum of these. So -1 plus √5 plus -1 minus √5. So if we add those together, we get -2. If we add those together, it goes away. So our sum is -2. And our product is going to be +1 plus √5 minus √5 minus 5. These cancel, and this ends up being -4. Now, remember, we we can turn it into a quadratic that's x squared. We take the sum, and it's the opposite of the sum, and then we take the product. So that's going to be our first part. Now, to get 2, that's just going to be x minus 2. And then to get this one, we're going to be x plus 1/3, but we don't want it to have a fraction, so we're going to think of it like it's equal to 0, multiply all the pieces by the denominator, 3x plus 1 equals 0, and so it's 3x plus 1. And then we just put an a out in front, and a cannot equal 0, and this is our polynomial. Those are all, that represents all of them. Okay, if you need additional help, please come to Math Lab. Until then, calculator.